Hi everyone, welcome back to Mind Maths with Amna. Today I'm going to solve questions given in chapter 4, random variables and the normal and sampling distribution, given in the Statistics 1 study guide provided by University of London for their EMFSS courses. The first question says that the random variable x takes the values -1, 1, 2 according to the following probability distribution. There's a 0.2 probability of x taking -1 value, k probability of it taking negative 1, and k taking positive 1, and 4k probability of it taking the value 2. Determine the constant k and hence write down the probability distribution. Okay. We know that the probabilities have to add up to a 1. So the probability of from the lowest to the highest value has to add up to a 1. So that means the probability of random variable taking value -1 plus the probability of random variable x taking value 1 plus probability of random variable x taking value 2. This should equals to a 1. So a 0.4 plus a k plus a 4k should equals 1. So we have a 5k is equals to a 0.8, and therefore a k is equals to 0.16. So the distribution is, let me tidy this up. Okay. So the probability of it taking value -1 is a 0.2. It taking value positive 1 is a 0.16. And it taking the value of positive 2 is k multiplied by 2, 4, which is a 0.64. Okay. So the x, they want us to find the expected value of x and the variance of x. Okay. So the formula for the expected value, as in the average, is the summation from the lowest till the highest of the random variable x, each of the random variables basically, multiplied by the probability. For instance, the first value is, it actually goes from a -1. Okay. So when x is -1, we need to multiply it with the associated probability, plus then x is a 1 and we multiply it with the associated probability, then x can be a 2 and we multiply it with the associated probability. So we basically get a -1 multiplied by 0.2 plus a 1 multiplied by 0.16 plus a 2 multiplied by 0.64. And this becomes a -0.2 plus 0.16 plus a 1.28, which is a 1.24. Okay, the variance. Okay, the variance of x is expectation of x squared minus expected value of x whole square. So we already have expected value of x, which was a 1.24. We just have to take the square of this number. However, we do need to find the expected value of x square, which is going to be the same formula, but since now we want the expected value of x square, then that means the random variable, this value has to be squared as well. So this thing is replicated. However, we no longer have the expected value of x, it's a x square. Okay, so we have a 1 multiplied by 0.2 plus a 1 multiplied by 0.16, then plus a 4 multiplied by 0.64. Okay, so we have a 0.2 plus a 0.16 plus a 2.56, which will give us a 2.92. So now we can easily calculate the variance. The variance is going to be 2.29 minus a 1.24 power 2. So the answer is a 1.3824. Okay, next question. The score on a verbal reasoning test are normally distributed with a population mean of 100 and a population standard deviation of 10. Okay. We know that any random variable x follows a normal distribution with mean mu and median sigma square, and the sampling distribution of the mean follows a normal distribution with mean mu and variance sigma square over n. Okay, so in this question we know that x follows normal distribution with mean 100 and variance 10 square. Okay, what is the probability that a randomly chosen person scores at least 105? Okay, so first we need to convert the normal distribution into the standard normal. Okay, so actually I'll just replicate this diagram here. So currently the mean is at 100. We need to convert it into standard normal, where the standard normal is such that it is distributed normally with mean 0 and variance 1. And the reason why we do this is because the statistical tables are provided for this. Statistical tables are provided for the standard normal. Okay, so whenever we say z is less than equals to some value z, the probability of this is given in the statistical table. I think it was table 4. I'll open it up and we can see. Okay, so the question says, what is the probability that a randomly chosen person x scores at least, so greater than equals to 105? So we can see 105 lies over here, and they're asking for the probability of this. We want this shaded region. Okay, so we're going to be looking for a value in the z table. Also, it's going to be we can see it's going to be a value above 0, and remember that the statistical table only gives me the value for less than equals to whatever this becomes, right? First, let's see what this value becomes. So let's convert it first. We'll have a x minus mean over the under root of the variance, so greater than equals to, so we have a 105 minus 100 over the under root of a 10 square. So we have probability of z being greater than equals to a 0.5. So basically this shaded region, let me shade it, this shaded region. However, the statistical table is given only for this region. So what we're going to do is, we know that probabilities have to add up to 1 for discrete distributions, and for a continuous variable like this, the area below the normal distribution should be equals to a 1, right? So the area below the curve over here and this should add up to a 1. Okay, so that means 1 minus, we can write this as 1 minus probability of z being less than equals to or less than, it's the same thing, 1 minus. One thing you should know that the area between an interval is positive, right? But area above a single point is nothing, right? So if I write the probability of z is less than 0.5, it is the same if I had written less than equals to a 5. The reason being that the probability under for a single point is 0. But the area between interval is going to be positive. Okay, so now I had to write a 0.5 here. So now when we refer to our statistical table, the value which will come is a 0.695, and when we deduct it from 1, our final answer is a 0.385. Let me find the statistical table and show this to you. Okay, so this is the table for the normal distribution. As you can see, it tells us the area shaded region over here, the area corresponding to this region. So we had a 0.5 over here. So let's see, a 0.5. So it's a 0.6915. That's exactly what I wrote. Okay, the second part. It says a simple random sample of size n is equals to 20 is selected. What is the probability that the sample mean will be between? Okay, first of all, the sample mean is going to be normally distributed with a mean 100 and variance 10 square over a 20. Okay, so we're going to use this in order to convert into z variable. Okay, so any z variable is going to be obtained when we do x bar minus 100 over under root of a 10 square over a 20, which is actually 2 multiplied by 10. So this cancels out, and then we have a 2 5s are 10. Okay, so an x bar minus 100 over an under root of 5. Okay, so we're interested in the probability of the sample mean being between 97. Okay, so probability it being between 97 and 104. So visually we could give ourselves this diagram. We know that the mean was at 100, so 104 must be over here on the right, and 97 will be here, and we're looking to find the area, which I'm going to shade right now. This is the shaded region that we're interested in. Okay, so first let's convert it into z. We're going to do a 97 minus 100 over an under root of a 5, and then 104 minus 100 over under root of 5. Okay, and this, after we use a calculator, becomes a minus 1.34 and a 1.789. So if we give ourselves a visual of this, the standard normal has a mean at 0, and we have a minus 1.34 here. So a minus 1.34 and 1.789. We want this shaded region, the area of this region. Okay, so we know how I can do this, that I can first find the area of this shaded region and then deduct it from the area that I find of this shaded region. So what we want to do is, I want to take the probability of z being less than equals to 1.789, which I can see from the statistical table, and I want to deduct it from the probability of z being less than equals to a minus 1.34. However, we have a problem here that our statistical table takes a value z which is on the positive side. So one thing that you have to remember at this point is that the z normal is actually symmetrical around the mean. So the area of this shaded region is going to be exactly the same as this shaded region. So the probability of z less than equals to minus 1.34 is exactly the same as the probability of z being greater than equals to 1.34. Okay, so these two things are the same due to the symmetrical nature of normal distribution. Okay, but however, the sheet doesn't tell us the probabilities after x. It tells us the region below. Okay, so that means since I know probabilities add up to a 1, I'm going to just write 1 minus the probability of z being less than equals to a 3.4, or strictly less than is the same thing. So 1 minus the probability at 1.34. Okay, so we're going to use this information here. We're going to say this is the probability under the graph when x takes value 1.789 minus 1 minus the probability when x takes value 1.34. So we want to find the probability under the graph when x takes value 1.789 plus when x takes value 1.34 minus a 1. Okay, I've become a bit untidy, but I think it's forgivable because I'm kind of tired today, so probably shouldn't record, but it's going okay so far. Okay, the first probability we want to know is for a 1.789. Okay, 1.7, where is it? 1.789, so 1.78. So somewhere between these two values, because actually 1.789 is like 1.79. So let's take the value 0.9633. Okay, so we have a 0.9633, then a 1.34. So we have a 1.34, 1.3, okay, 1.34. We have a 0.9099, 0.9099 minus a 1. When we use a calculator, we'll get a 0.8732. Okay, the next question, and I think that's enough for this video. The weights of a large population of animals have a mean this and standard deviation this. Okay, so x is the random variable that denotes the weights of this population of this animal, and it's normally distributed with mean 7.3 and 1.9 being the standard deviation. Okay, assume that the weights are normally distributed. What is the probability that a random selection, so we have a sample here. Remember, when x is normally distributed with mean mu and variance sigma square, then how we convert it into the z is that you take x, whatever the value of the random variable x is, you minus the mean of the population, you take the under root of the variance. Okay, so basically the standard deviation. If the sample mean is distributed with mean mu and variance sigma square over an n, then the z distribution is going to be x minus mean and the under root of the variance. So we're going to get sigma over under root of n. Okay, So in our question, we have a sample that's being selected with of size 40. Okay, so we have a 7.3 and then a 1.9 square over a 40. Okay, we want to what is the probability that the mean weight will be between sorry, will between 7 and 8. 7 and 7.4. Okay, 7 and 7.4. So first we have to convert it into the standard normal in order to use this statistical table. So we have a 7 minus a 7.3 over a 1.9 over under root of 40, and then this is going to get converted to z, and then a 7.4 minus a 7.3 over under root of the variance will give us this. Okay, we take out our calculators and we make this calculation, and we'll get this minus 0.9986, and z this we're going to get a 0.3328. Let's just do it, correct it to 2 decimal places. This will just become a -1 actually, and this will become a 0.33. Okay, so again, this is the probability of z being less than equals to a 0.33, and due to symmetricity, actually let's just write this down, and z less than equals to a -1. Okay, this value we can already see from the table. However, this is not available because the value of x as in z should be a positive number. So we're going to use the symmetricity property over here. And then the next property that we're going to use is that probabilities have to add up to a 1. So we're using this property. Okay, so then we have the probability at 0.33 plus probability at 1 minus a 1. So let's see a 0.33. First, let me erase all of this. A 0.33, let's search for it. 0.33, then 0.33. So it's a 0.6293. A 0.6293. Okay, at 1, this is a 1. 8413. Okay, 8413 minus a 1. 0.4706. So there's a 41.1% chance that the mean weight is going to lie between 7 and 7.4 kilos. Okay, a researcher stated that the probability you calculated it is approximately correct even if the distribution of the weight is not normal. Do you agree? Yes, we do, because of the central limit theorem. The sample is 40, which is a large sample. So even if the original distribution was not normal, as in it wasn't a continuous distribution, as long as your sample size is very large, we can use the normal distribution as an approximation for that. So imagine if you have an original distribution which is discrete. For instance, let's suppose a random variable x had a binomial distribution, but you took a very large sample, anything above 30. So let's suppose you took a sample of 100. You can actually approximate the probabilities of that binomial distribution using the standard normal distribution. And you can even draw an histogram and see how it will look like the distribution is kind of, it's very rough and very bad. It will look as if the distribution, despite being discrete and despite us drawing a histogram for it, that the distribution is normal. So yeah, the answer to the next question is that yes, according to the central limit theorem, you can approximate it using the normal distribution. There were only 3 sample examination questions given in the study guide. However, the study guide does give us worked examples and as well as practice questions, which I will solve in the next video. I was kind of clumsy today because I'm tired. My aunt passed away yesterday, so my brain isn't working. There's too much brain fog. So apologies if this video wasn't that great, but I still hope that it helped. And have a nice day. I'll see you in the next one.